Hi everyone, in this video we're going to be learning about displacement vectors. Now, given 2 points, such as the point A and the point B we see here, we can define a displacement vector between those 2 points whose components tell us exactly how to get from point A to point B. And so we could quickly draw that vector AB. That would be the vector joining point A to the point B, like so, and it would have an arrowhead pointing at the point B. And I suppose I could even label that AB with an arrow on top of it. There we go. So vector AB tells us here how to get from point A to point B. And of course, we need to know how to define a displacement vector in component form. Here's what I mean. We can go ahead and say that the vector AB, which we write with capital A, capital B, and an arrow on top, well, it's equal to, well, it has 2 components, right? It has a horizontal, or X component, and a vertical, or Y component. And to figure out what those components are, we're going to be seeing 2 methods. One of which I'm sure you already know of. We can just read those components directly off the illustration we have here. And here's how. To get from point A to point B, starting from the tail of vector AB, we can see that to get from the tail to the head moving nothing but horizontally and vertically, we need to move 1 unit to the right and 1, 2, 3 units upwards. So that tells us that the horizontal component is equal to 1, and the vertical component, well, that's equal to 3. They're both positive because we moved to the right and we moved upwards. Those are the 2 positive directions. And there we go. Those are the components of the vector AB. But now, alongside knowing how to do this, that is, find the components of a displacement vector from an XY grid the way we just did, we also need to know how to do it using a formula. And that formula involves the X and Y coordinates of the starting point of the vector and the end point of the vector. And so let's see, here I'll write it for 2 very generic points A and B, and I'll say that the point A has coordinates XA and YA, and that point B has coordinates XB or X sub B and YB. Now, given those 2 generic points, we can define the vector AB as vector AB is equal to the vector whose components are XB minus XA and YB minus YA. Done. And in fact, I'll go ahead and box all of that. Do make a note of it. There we go. And so just to illustrate how we can actually use this formula, let's go ahead and use it to find the components of vector AB again, which remember we already know are 1, 3. So let's see, I'll do that in gray underneath here, and I'll just remind us of the fact that A has coordinates 1, 2, that's the point A, not vector, and B has coordinates 2, 5. Again, that's the coordinates of a point. We're not speaking of vectors yet. Using those 2 points, we can now define the vector AB, which will equal to, in component form, the x-coordinate of point B minus the x-coordinate of point A, so that's 2 minus 1, and in fact I'll write that out, that's 2 minus 1, and the y-coordinate of point B minus the y-coordinate of point A, so that's going to be 5 minus 2. And again, I'll write that out as well, 5 minus 2. There we go. Now we quickly calculate that. 2 minus 1 is just 1, and 5 minus 2 is 3. And there we go. We can see that we get exactly the same result here as we did by reading those components off of the XY grid. And in fact, you could probably question, okay, well, if I can do it with the XY grid, why bother with this formula? And the answer to that is simply that at times we won't be in a position to read anything off an XY grid. We may be dealing with very large numbers, and numbers which aren't as friendly as 1, 2, and 2 and 5. So it's important to have a formula to properly define a vector the way we just did. That being said, let's go ahead and quickly find the vector AC. So that's the displacement vector whose components tell us how to get from point A to point C. And in fact, we could even draw that vector. That's the vector starting at point A and ends at point C, like so. So that's the vector AC. And we could find this vector's components in 2 ways. Of course, we could read the components directly off the XY grid again. And in fact, we could start with that, couldn't we? We could just quickly say that vector AC is equal to, well, let's see. To get from A to C, we need to move 1, 2, 3, 4, 5 units to the right, so that's positive 5, and 1 unit upwards. So vector AC is equal to 5, 1. Okay, now let's confirm that result using the formula that we have boxed in orange here. So let's go ahead. We could say that vector AC is equal to the vector with components. Let's see, we'll have xc minus xa. So I'll just write that at the top there. That's xc minus xa. And the y, or vertical component, will be yc minus ya. Let's write that. That's yc, or y sub c, minus ya. Now, since A has coordinates 1, 2, and point C has coordinates 6, 3, this quickly turns into 6 minus 1 and 3 minus 2. And finally, we can state that the vector AC, or the displacement vector AC, has components 6 minus 1, which is 5, and 3 minus 2, which is 1, which confirms the result we had found directly off the XY grid. And there we go. We've now defined the displacement vectors AB and the displacement vector AC. Now let me finish this video by pointing out something quite important. Given any 2 points such as A and B, we can define 2 displacement vectors. One of them is the displacement vector whose components show us how to get from point A to point B, and the other is the displacement vector whose components show us how to get from the point B to the point A. So that would be the vector BA. And in fact, I'll draw that on the same XY grid here. And let me draw that in a sort of green here. So starting at point B, vector BA points towards the point A, like so. There we go. That's the vector BA. Now, what's important to realize here is that the vectors AB and BA are opposites of each other, and consequently, their sum, so AB plus BA, with the arrows on top, like so, will equal to the 0 or null vector, which I write like so. And that's quite an important result, so I would definitely go ahead and box that. There we go. And in fact, we could convince ourselves of that result by quickly defining the vector BA with the formula we have here and the coordinates of points A and B that we have here. Indeed, we can go ahead and state that the vector BA will equal to the x-coordinate of point A minus the x-coordinate of point B, and the y-coordinate of point A minus the y-coordinate of point B. Notice that when I'm writing these, I know that the coordinates that go first, the x and y coordinates that go first on each of these 2 components, are always the ones of the end point of our vector. That is where the vector points towards. That being said, I carry on. So xa minus xb will be 1 minus 2. Let me just quickly write that. So we'll have 1 minus 2. And ya minus yb, well, that's going to be 2 minus 5. So that's 2 minus 5. I carry on. 1 minus 2 is negative 1, and 2 minus 5 is negative 3. Let me just tidy that up. There we go. Negative 3. There we are. So that's vector BA. And clearly, we can see right away that vector BA is equal to the opposite of vector AB. And so we can even write that here. That's equal to the opposite of AB. And there we have it. That's it for this first video on displacement vectors. In summary, a displacement vector is a vector whose components tell us how to get from one point to another. At times, we'll be able to find a vector's components directly from an XY grid like this one, and at other times, we'll need to make use of the formula that we boxed in orange here. Finally, we've seen that given any 2 points, such as A and B, we can define 2 displacement vectors which are opposites of each other. And all of that being said, that's it for this tutorial.